Hello and welcome to TGI Kubernetes. My name is Joe Beda and this is a bit of an odd edition. Here we go. Can you all hear me fine? I'm working from home today because it's actually a holiday here in the US. It's Veterans Day. And I tweeted out that I was going to do TGIK, and then I realized it was Veterans Day, and I figure I'll do it anyway. So a little bit of a different setup here in my home office. So I just want to make sure it sounds good. All right, cool. Nice to see you, Suresh and Richard. And because of daylight savings time, a lot of folks who aren't on daylight savings time got a little confused on the time here. So just for the record, I'm not a fan of daylight savings time. We actually did this thing where we did this. We have like one big YAML file for all the SIGs in Kubernetes, and we had the meeting times in there, and those were expressed in UTC because that seemed like really nice and fair to actually sort of like do it in a way that's not super time zone specific. But the reality is that all the SIG meetings track daylight savings time, and so now all those things are wrong. And so last week I had to go and modify that so you could specify a time zone. Nice to see you, Walid, Angel. I'm sure I'm pronouncing your name, or Angel, Angel, Jose. Good to see y'all. So today our plan is to go through Contour, which is this project that Heptio. Developers don't have holidays. Yes, you should have holidays. Everybody should take some time off when they need it. That's part of being making this industry work for you. Federico, good to see you again. So today we're going to go through a project. This is a Heptio project called Contour, which is an ingress controller based on the Envoy proxy, which is a CNCF project. It's a load balancing proxy, HTTP proxy that has been proven out at Lyft, the sort of car sharing company. And they've been using it for a while, and it's a really interesting design that lends itself really well towards Kubernetes, which is one of the reasons why we built an ingress controller. Now, this particular, so hi, Chris, how's it going? So Chris Nova is just going to go and climb for 3 days, and so right after this, I think she's going to go climb a mountain. And I think she was going to try and set it up so you could follow her on Twitter and actually see where she's at. I don't know if she's going to end up doing that. Aslan from Berlin, nice to see you. Yeah. So that's what I'm going to go through today. So I'm going to talk a little bit about Envoy and what makes Envoy special and why it's so interesting. I'm going to talk about the ingress controller that was built by Dave Cheney of Go fame. He's in Sydney. I don't know if he's going to join us today or not. Jose wants you to go to New Zealand. You should go to New Zealand, Chris. And then we're going to talk about the different ways to deploy something like Contour. And along the way, we're going to cover some of the ins and outs and sort of like where Contour is as a project and some of the stuff that's going to be coming. Burr, nice to see you. Nuatu, nice to see you also. And then I have a new toy here in my home office. I have this thing called a Glowforge, which is a cloud-controlled laser cutter for doing all sorts of fun stuff. And so it's made by this company here in Seattle. A friend of mine runs it, and they've been working on it for 2 years. And so I want to give a demo of that. So we got a lot to cover here. So one of the things that I like to do when I start out is go over some of like what's going on in around the Kubernetes world, and so I don't have much today. But the one thing I do want to talk about, and folks were talking about it in the chat beforehand, is Justin Garrison and Chris Nova, two folks who are very active in the Kubernetes community, wrote this book that's now out called Cloud Native Infrastructure, and I hadn't ordered it, and I just ordered it just now. So you can see you purchased this item on today. So there we go. So I just bought the book. I haven't read it yet, but I'm really excited about it. And oh, you were just talking. Okay, so Walid said he was talking about it at a local Docker meetup, which is great. I know, Chris and I, sat down and she interviewed me a little bit for it, so I'm sure I show up someplace there. Hey, Elric, how's it going? So I haven't read it yet, but I'm sure it's awesome because Chris and Justin are both awesome. So I don't see how it could be anything but. So I just wanted to give a quick plug out there for the Cloud Native Infrastructure book. Yeah, we're gonna get to lasers, Chris. Don't worry. So yeah, is there anything else that's going on? Hey, Sam. Is there anything else that's going on around the Kubernetes world before we move on to sort of the main event here around Contour that folks want to ask questions about or talk about a little bit? I usually want to, like, if there's something I forgot, something interesting going on, it's always fun to be able to bring that stuff up. I think things are a little bit quiet. Oh, there's one other project that I think is interesting. It's Weaveworks Flux. So Weaveworks is this company in London. They make the Weave networking stuff, but they're doing a bunch of other stuff also. And the Flux project was originally a sort of, microservice proxy sort of, mesh type of thing. As they started working with it and sort of it morphed, apparently. And I hadn't seen this. I hadn't looked at it forever. And it morphed to being essentially a continuous delivery project, which is kind of a little bit interesting that it morphed all the way from being like a proxy on the networking side to something that's being, all the way to continuous delivery. And I haven't played with this, and it's something that I might want to do on a TGI also. But Flux is now a way that you can have your configuration for Kubernetes checked into Git, and then maybe I'll take that up next time. So, Chris, are you seeing? So different people have different delays on this thing, and I set YouTube to try and do a short delay. But depending on how you're connected or sort of like, what kind of buffering you have going on, you may see different amounts of delay. So I apologize if there's a lot of delay there. It's one of the downsides of doing the broadcasting like this. And I think all the platforms pretty much, including like Twitch, have a similar type of delay. So that's unfortunate. So I will just talk, I'll monologue, but you guys can feel free to comment. It'll just be a little delayed. But Flux looks really interesting because it's a way of checking in your configurations into Git and then having something that's monitoring Git and automatically taking what's checked in and then pushing it. And there's some other cool features that are going on there too. So this is something that's really interesting, and one of the things that we've been looking at a lot at Heptio is how do you define your application configuration. We've been working on this project called KSonnet. We have some really interesting things in store there, and I'm really interested to see if maybe that will work well with something like Flux or a similar system for essentially taking an application definition and then going ahead and deploying that. My dog's here too. He's barking. My son's having a friend come over, so that's going to be exciting. Okay, Diego from Vancouver. Nice to see you. You're at least in the same time zone, so there we go there. All right, so the CNI book, Flux. Let's keep moving here. So Contour, so Heptio Contour. So this is an Ingress controller to drive Lyft's Envoy proxy, and it's a brand new baby project. Dave Cheney, who is pretty well known in the Go community, started this when he started working for us at Heptio, and has made some amazing progress with it. It's still a very early project. The biggest feature, and I'll just get this out there right now that it's missing, is it doesn't do TLS termination. And so most of the time when people are running Ingress, you're going to run it through with something like Certificate Manager or kubelego that'll work with Let's Encrypt or what have you to be able to provision certificates automatically. That's not supported yet in Contour. It's something that we're working on. And the TLS support in Envoy itself is evolving to actually support this use case a lot better. So Envoy right now doesn't support SNI, which is the technology, the protocol needed so that you can support multiple sites, sort of virtual sites on a single IP address. So that's not supported yet. So that's the big reason why TLS is missing from Contour. But other than that, it's a it's a pretty solid, implementation way of configuring Envoy. Now, the big question is, why did we do this? Most folks right now are using Nginx as their ingress controller, and you can make that work. But based on the limitations with the free version of Nginx, the way that you reconfigure Nginx, and this is the way that the ingress controller works, is that it essentially writes out a file and then causes Nginx to actually do a restart to be able to pick up that new configuration. And when you're in a dynamic world where there's a lot of things coming and going, that model of having to actually restart the thing isn't a great fit for Kubernetes. Actually, let me back up a little bit. I did do an episode of TGI on Ingress, but would it be worthwhile for people? I'm going to give a little bit of a recap on what Ingress is. I don't have my document camera, so I'm not going to draw fancy diagrams like I did in the previous episode. So go check that out if you want to go really deep there. But pretty much what Ingress is it's a layer 7, which generally in this context means HTTP, HTTPS, HTTP2. It's a layer 7 proxy. Okay, so Angel said, so there's an HA proxy ingress, there's traffic, which also can act as an ingress controller, and then there's the Nginx one right now, too. Yeah. So yeah, and there's, if things are created in the wrong order, you can get into problems also. But so Ingress is a system for configuring layer 7 load balancers. And so when you're running something like Nginx as a load balancer or HA proxy or whatever, you have a configuration file on disk, usually. And that configuration file describes, hey, if a request comes in looking for this site under these circumstances, I want you to load balance it across these things on the back end. And as you add more and more sites to an Nginx config, what you find is that config file or that config file tree gets bigger and bigger. Ingress is a way to describe that configuration in a relatively generic way across a bunch of load balancers, and then collect all that stuff together so that you can have a bunch of different pieces that go into that configuration all consolidated for you. So it's a way for essentially driving configuration of one of these load balancers. Let's see. So yeah, HA proxy, I believe, does the same thing with respect to the having to have a file on disk and then reload it. So what makes Envoy special? So first of all, here's the Envoy website. One of the interesting things, and this is not a reason to use a technology, but it's kind of nice to know that there's a certain community behind it. Envoy is now a project that is part of the Cloud Native Computing Foundation. And so what this means is that there is long-term governance of the project. It's something that the Linux Foundation essentially is going to be a steward of this project for quite a while. So that's actually really going to be really cool. But the coolest thing about Envoy is that it's all API driven. Now, if you go to the documentation here, it can actually run off of a configuration file that is, a big old JSON file that's similar in some ways to the Nginx or the HA proxy configuration file. But everything pretty much that's delivered in that configuration file can also be done via an API. And right now, this particular GitHub repo that I'm looking at is the V2 APIs, which are in active development right now. Contour is not using the V2 APIs yet. We're using the V1 APIs, but in the next version of Contour, we're going to switch to the V2 APIs, and I think Contour is going to probably be one of the first projects that's going to be using these V2 APIs. But the way that this works is that Envoy is totally API driven, which means that you don't have to sort of write this config to disk and then tell Envoy to reload itself. It turns out, hey, Mateus from Brazil, nice to see you. So it turns out that Envoy is dynamically configured without having to do any sort of reload type of mechanics, right? Which it's built for that dynamicism that you're going to get when you're running in an environment like Kubernetes where things are coming and going all the time. The other interesting thing about Envoy is that if I were to actually think about, and you said an API-driven load balancer, what I would expect is that you could actually call into the load balancer via an API and poke configuration into it. So, hey, I want you to reconfigure this and that. It turns out that Envoy works the other way. You configure Envoy with an API, and then it calls out to that control server to actually say, hey, what configuration should I be using? And the interesting thing here is that the relationship between Envoy and the controller that's actually configuring it is very, very similar in concept to the relationship between the kubelet in Kubernetes and the API server. So the kubelet calls into the API server saying, what should I be running? Similarly, Envoy calls into the Envoy controller, and there's actually a set of APIs that can be split across servers, but calls into the control plane server for Envoy and says, hey, how should I be configured? And so that model, again, is a really good fit for the Kubernetes world. So Sam's saying, does it use a gRPC gateway for REST? For the V2 stuff, I'm not sure. I'm not sure if it's natively supports REST or whether it's using the gRPC gateway. That's a good question. I do know the work that Dave's working on, and he's made some good progress with it using these V2 APIs. He's just using the native gRPC stuff. So that's where he's at. And so what you'll see is that, and if we go down here, here's the list of APIs that are being driven in V2, and there's some really interesting stuff here. There's what are your set of backends? What are the endpoints for those things? Are they healthy or not? It's a way to essentially sort of, if you're health checking, you can take those health checking results and broadcast that. Rate limiting, metrics, all sorts of really interesting stuff going on here. I'm not going to go into all the details of this, but I think, for me, this is the thing that really makes Envoy special. It's also written in C++. It's fast. It's really fast. Anytime you're dealing with packets and connections, you definitely want to make sure that things are fast. All right. So that's enough sort of talking here. Let's go through and demo this. Let's see. So Dave just slacked me. He said he does have the gRPC support working in a branch. He just didn't want to merge it before I went ahead and did TGIK. So he didn't want to push new stuff right before we went ahead and did this. Let's see. And the authors are amazing. So the authors of Contour, well, Dave's amazing also. And then the Envoy. Okay, more stuff about, I'm going to sing more Envoy praises. Matt Klein, who works at Lyft, is really great. Chris, you're allowed. You're on vacation, going on a big climb. Let's see. So Matt Klein's amazing. The team at Lyft are doing that. Google's putting, and this is for both Istio and places where Google's using Envoy internally, are putting a ton of resources into Envoy also. And so it's getting a lot of performance and extensibility and hardening from a security point of view that is really going to benefit everybody. And so a lot of exciting stuff going on with Envoy there. All right, so let's go ahead and get started here. So this, my instruction for getting started, and I have a plain Jane cluster that is one of our AWS Quick Start clusters that I'm going to apply this to. So the first thing we tell people to do here is a kube control apply -f, and then we point through this redirector here to actually get a YAML file that you're going to download. Now, I'm not proud of this. We really wanted to make this be as easy as possible. The redirector that we're using at Heptio doesn't support TLS out the gate. So this should have, and this is something I'm probably going to fix next week. There should be an S here. We really want to do that. And even so, my advice to people is before running something like this, you want to dig in and really understand what's going on. Most people aren't patient enough to do that. We do give you a little bit of a rundown of what's going to happen here. But let's go ahead and download this because that's a best practice before we're going to go ahead and actually run it. So did you consider building Contour on top of Traffic? Or was it a pretty easy decision to target Envoy given the community? Honestly, we didn't look at Traffic very closely in terms of this stuff. I think the some of our plans and where we really want to sort of take Contour over time is to be able to go and handle very, very large sort of company-wide horizontally scalable ingress installments, right? And so, and talking to Matt and the folks at Lyft, this is one of those places where Envoy is already being used in that capacity in some companies, and so at Lyft, specifically. And so I hadn't heard the same thing about traffic. So just looking at the APIs, looking at the community, Envoy really seemed like a slam dunk for us out of the gate. And traffic already has an ingress controller that works, but in terms of sort of where we want to take Contour over time, I think Envoy ends up being a great fit for us. Okay, so let's go through and I'm going to do make dir Contour and curl-l. We're going to do that. Let's see. Is it O that I do that? There we go. And then we'll look at this, and we'll see what's going on here. All right, so there we go. Now this, I wrote this stuff here, so I know exactly what's going on here. And one of the things that we're going to be doing probably over the next month is the configuration for generating this is going to be driven by KSonnet. We're going to actually start bringing stuff together here. What this is it's a concatenation of a bunch of files that are in the deployment directory here. So we're looking at this one here. So it's all these files concatenated together. But what we're going to do is we're going to create a Heptio Contour namespace. We're going to create a service account for this thing. And then for the service account, we're going to give it permissions for to be able to read config maps, endpoints, nodes, pods, and secrets, right? And the secrets are so yeah, Alex, my keyboard is the new MacBook Pros with the shallow keys, but I really like to pound on the keyboard, so these things end up being really loud. So secrets ends up being so that you can read TLS secrets. It's probably not necessary for Contour where it is now, but as we start supporting TLS in this context, it's going to be necessary. The fact that most ingress controllers end up being able to read all secrets across the entire cluster is not something that people are happy with, and I touched on this on the previous episode on Ingress, but it is sort of where things are right now. And so we're looking at services, and then ingresses we also need to be able to do. Right now, Contour doesn't actually write back to the ingress for status. It's something that like the Nginx controller, ingress controller does. That might be something that we add in the future. When that happens, this thing is going to have the ability to also update the ingresses to actually put status in there. And then in this particular case, we're running ingress, we're running Contour. And there's two containers in an init container going on here. So the two containers are Envoy itself, and then Contour. And so what we do is we set up Contour to actually run as a sidecar right next to Envoy. So for every Envoy, you have a version of you have an instance of Contour running right there, and those guys get paired buddy. You could also, and we haven't done this yet, but it's also conceivable that you could have a fleet of Envoys running talking to a smaller set of Contour servers, right? So these things don't have to be paired one-on-one, but for the ease of deployment, that's how we started out doing this. Contour is, a relatively small daemon, so the overhead of running one on a sort of buddy-buddy situation is really not that great. And then we have this init container here, and this does nothing more than writes out sort of a bootstrap JSON file for configuring Envoy. Zoom in on that YAML. Okay, is it too small? Here we go. We'll do that. And we'll do that. Is that easier to read for y'all? And so the init container is going to run Contour in sort of an init mode that writes out a super simple JSON file to essentially tell Envoy, hey, for all your configuration needs, talk on localhost to Contour, right? It's essentially telling Envoy to use localhost to get all its stuff. And so those things coordinate with a volume with an empty dir. So the way when this pod starts up, the init container runs, it writes a simple configuration file into an empty dir volume, and then both Envoy and Contour start. Contour is going to use the service account to actually get all of its stuff from the Kubernetes world. And then it's going to translate and serve that to Envoy over localhost locally. So that's what we have going on there. Envoy is HTTP 2 aware. I don't think I've tested it yet with Contour. One of the things that's necessary really for HTTP 2 to really work is TLS. Those things end up being pretty tied, and so as we get TLS supported with Contour, I think I think we're going to get H2 support for free. The interesting thing about Envoy is it supports H2 both for incoming connect, for upstream and downstream. So downstream being the people calling into Envoy, upstream is the thing that Envoy calls, right? So it can actually pass H2 between those things, I believe. Which is one of the reasons why Envoy was chosen as the data plane for Istio also. Small digression here. Istio does also support Ingress using Envoy, and so there's a lot of overlap there conceptually, but most of the time when people are using Istio, it comes along with a whole host of other concepts. And one of our goals with Contour was to really have something that was simple and purpose-built for Ingress, essentially what people call north-south traffic, whereas Istio is taking on a much more complex problem in general. Over time, we may see these things start to converge, in which case, that would be an interesting place for things to go. And then finally, we have, in this particular deployment, we have a service of type equals load balancer. This will go ahead and create an ELB. If you happen to run this thing in Amazon, we have an annotation on here saying we want to run that ELB in HTTP mode. And when you run the ELB in HTTP mode, it'll actually go ahead and add the X forwarded for header so that you can see the original IP address that for whoever's connecting to this thing. Yes. Okay. So let's go ahead and make this happen. So kube control get. Let's do version. Am I working? No. Oh, I restarted. So eval. AWS demo. Okay. So KTX, this is in Heptio Labs. This is a project that Chuck Ha, who works for us, wrote. It's super simple stuff. Some people manage multiple clusters by putting them all into a single kube config. An alternate way of doing this is that you can have multiple kube configs, and then you can set environment variables to actually set which one is live. This will help you actually manage the environment variable for being able to set which kube config live you want to actually use. So now I can do kube control get nodes. That'll show me what's going on here. It's a 182 cluster. And then let's do kube control apply -f this thing here. So we're going to create a whole bunch of stuff. That's all that we expected to happen is happening there. Now I got to talk for a while because it takes forever for ELBs to start up on Amazon. What we're doing here is we're doing a deployment, which means that we're going to run two different copies of Envoy and Contour. Let's see, yeah, and let me go through what's going on there. So we're running a deployment with two of these things. But you generally don't want these things to land on the same node. And so we have here a affinity stanza in the YAML here, which is essentially, and this is way harder than it should be, but essentially what I'm trying to say is try not to run multiple contours on the same node, right? It's saying based on host name, make sure that we have anti-affinity. So have these things sort of like, try not to actually do that, for any other pod that has the app equals contour label on it. That's essentially what we're saying here. would be interesting if you have time for you to CPU limit that deployment to 0.4 millicores. You don't want it to smash other running production services. That's a really good point. I think, and it's something that I haven't been very diligent about up until now. If you're running Kubernetes in a production environment, you really want to make sure that you set limits on everything. In fact, I think it might be a good TGIK episode to really go through how limits work and what we can do to make sure that people are using them appropriately, looking at both limits and quota, and what it looks like when, say, you run out of RAM. We can sort of play with things and the killer and stuff like that. So it's a really good point, Richard, and it's something that I think is probably worth its own TGIK episode to really go into that. I'm not going to try and do that live because I haven't tested it out yet. Yeah, so this is up and running, and we should have these two running on two separate nodes. The other method that we have, and we have YAML provided, is that you can run this as a daemon set. And what that essentially says is I want to run Contour on every node, or at least every node that matches a particular label. So you could have, say, a pool of nodes, and you could say I want to run Contour on every node in that pool. It's for large production clusters. It's a lot of times what people do is they'll have a dedicated set of nodes just for running ingress and incoming load balancing. That's really different from everything else. Richard says, yeah, so having dedicated info nodes for different purposes it can be good practice. So try running Spring Boot class path scanning, sort of 100 seconds of time. Yeah. So yeah, this is one of those things that you'll see, and I saw this running Java apps on Borg, is that if you don't start putting limits on things, Java can take a long time to actually get itself up and running, which also is a good argument for readiness probes, right? Because sometimes even though the process is running doesn't mean that it's ready to actually receive traffic. Okay, so let's go see kube control namespace Heptio Contour get services wide. We can go ahead and let's open this puppy up, and it's not ready yet. Let's go back and hit refresh until it shows up. Let's see what's going on here. We have our load balancer here. And this is a classic load balancer. It looks like instances in service. It should be good. 404. Oh, wait, actually it is working, but I'm getting a 404 because there's nothing there. We don't have anything set up with the ingress. Now, you can run ingress in a couple of different modes. One mode is you can say, hey, I just, whatever comes in, I want you to actually route it to these backends, to these upstream servers, or you can actually key things off of host names. To avoid mucking with DNS, which is always a little bit tricky, we have here, if I go back, to our getting started stuff, I have a really simple example application using QuarD, which we've used before here. And I'm going to go ahead and curl that also. Not dash. Oh, what? Okay. Oh, all right, where is that? What do we have? Curl -lo. There we go. Okay. Move, contour, QuarD example. Okay. And let's go ahead and we'll look at what we're going to be doing here. So this is going to create a deployment with 3 replicas running QuarD. We're going to set up a service for this, which is targeting port 8080 from port 80. And then we're going to set up an ingress saying anything that comes in, send it to this thing. And so let's go ahead, kube control -f, apply -f, contour, QuarD example -f. Okay. So we're creating the deployment, the service, and the ingress. This is all happening in the default namespace. Though that should come up pretty quick, hopefully. And so now if we go back here, yay! Okay, we're up and running. That's great. One of the things that we see here is we see x forwarded 4 is, this is the original IP address. I just gave away my home IP address. I That might have been a bad idea. Who knows? And then this is the address that Envoy saw the thing coming from. So this is essentially, I believe, this might be the AWS ELB address that you're actually seeing here. Yeah, Chris. Yeah, I'm not going to talk about that, Chris. I'm not going to call you out there. So we got Envoy up and running here. With configured through Contour. Everything's working great. So that's it, honestly. Now, as we get more features into Contour, including TLS, I think it's going to be worth another demo. What I want to do now is I want to do an advanced configuration, advanced deployment of Envoy using AWS NLB. And this is something that I think I talked about a little bit in terms of at the previous Ingress episode. I've had a chance to play around with that, and I wrote up some instructions on how to do that. Let's see. Is enabling Hsts and Ingress available? I think, a lot of times what happens is different Ingress controllers will allow you to use annotations to describe sort of whether you want to enable certain features like Hsts. That's something that we're going to be looking at with Contours in terms of which annotations do we want to support, how do we want to actually enable certain options like that. So, as we start doing this, that we're going to be looking for people with feedback in terms of what features we go ahead and add there. And then also, if you want to get involved, it's a really nice code base because, Dave wouldn't do anything else. And and so feel free to submit some PRs there. We're definitely would love to see that. Okay, so what I'm going to do now is I'm going to actually tear down my Envoy, my Contour. So I'm going to do kube control. Let's see. I'm going to do delete -f. So there's two things that we can do here. We can just delete the namespace, or I can delete it through the YAML file that we had originally. Oh, now you're just making it worse, Mateus. You're just like really broadcasting my IP address out there. All right. So the next thing we're going to do here is we're going to do an advanced setup of Contour. And if you go down the page here, where did I put it? It's someplace. If you go to deployment documentation, and then we have like advanced stuff. You can run without a load balancer, say if you're running with a stack of Raspberry Pis. But then we have this AWS NLB. So Stefan says, is it possible to set up Ingress using ALB instead of ELB Classic? So there are projects out there, and I think there's probably like 2 or 3 at this point, that essentially are Ingress controllers that then go out and actually configure ALB. I think the one, like, look, I had searched for this before. Zalando is this German company. It's a German retailer. Oh, thank you for live port scanning my home IP address, Chris. I appreciate that. So Zalando is this this German retailer, and they wrote an ALB controller that they had talked about, I think, at KubeCon Europe a little while ago. I think there is a PR in Kubernetes to add NLB, but I don't know if there's a PR in progress to add ALB. Chris might know off the top of her head. I'm not sure. Quick sort of like, so early on there was ELB, Elastic Load Balancers. It's now called ELB Classic. And it could run in either TCP mode or HTTP mode. Both of those things were not super configurable. You couldn't actually sort of do different routes in the HTTP mode. When you did the TCP mode, it would still terminate connections so that you wouldn't actually see the originating IP address coming in. Over time, Amazon has actually introduced 2 new types of ELB, ALB, which is really sort of a L7 load balancer, something that is a peer to, say, something like Envoy. And then they've introduced NLB, Network Load Balancer, which is a TCP type of thing that doesn't actually terminate the connection. So it does some fancy natting tricks versus doing the terminating the connection. Okay, so there is one then for ALBs. I haven't actually gone ahead and played with that. Yes, could I implement a Bitcoin miner in the next version? I probably should, or at least do something that takes a lot of CPU, so that we can. Maybe I'll do that in preparation for the resource limits episode of TGIK. Okay. So the Zalando thing is actually, I know that's something these guys are using this stuff in anger, so that's super interesting. But apparently there's other PRs out to actually support ALBs. I haven't been tracking that stuff super carefully. All right, so let's install Contour with NLBs. Now, like I said, there is a PR out to actually support NLBs natively. So you can do type equals load balancer and then probably an annotation saying use an NLB versus an ELB classic. That's probably where we're going to actually show up. Oh, look, there's a bug there. Okay, in this markdown. Okay, but now what we're going to do instead is we're going to, oh shoot, I'm going to have to clone the Contour repository. So let's go ahead and do that first. I don't have that handy, sorry. So I'm going to clone that into something called repo. Okay, and go back a couple times. Oh, no. Sorry, I lost my place here. Where was it? Here's the NLB tutorial. And then what we're going to do is we're going to actually do a kube control applied to a directory. So let's do repo, and then let's look at actually what we're about to do there. So if I go repo, deployment, we have this thing called ds hostnet. Okay, so we have the namespace, RBAC. This is the stuff that we all had before. These are actually soft links within this directory. And then we're going to do a daemon set. And we're going to, not only are we going to do a daemon set, we're going to do a daemon set that uses host networking. And so what we're essentially saying is that this is a special container that I don't want to contain the networking. I want it to use the host networking directly. Usually, like if you're going to lock down your cluster at all, this is something that you need a little bit more permissions to be able to do. So, and typically this will be most appropriate when you're running on a dedicated set of nodes. You could run this with the pool with everything else, but typically you're going to run it as a dedicated set of nodes. And what it means is that the Envoy will be listening directly on port 8080 on the host without any sort of bridge, without any sort of nav, without any sort of like overlay network going on. And so that's the biggest change that we have here. It's a daemon set, so it'll run on every node, and it'll listen directly on port 8080 is where Envoy is going to actually be running. So we're going to go ahead and set that up. We're going to deploy that. If you point kube control apply -f at a directory, it essentially installs all the YAML files in that directory. So that's up and running. That's running right now, but we're not going to be able to reach that because it turns out that it's like I said, running directly on the node. There's no service there. There's no cluster IPs. There's nothing, right? It's just running on the node. I could SSH into the node and curl. Maybe we'll do that while the NLB is actually spinning up. Now we have to configure the NLB by hand. So let's go ahead and do that. So the first thing we're going to do, and again, this won't be necessary as I was already there. This won't be necessary as NLB support gets merged into Kubernetes. Hopefully that'll come in the next version. But now you can actually see, oh, look, I can do the classic load balancer. That's what we had before. There's ALB and NLB. Let's go ahead and we're going to create an NLB. Let's give it a name. Let me look at my where's my instructions here? Okay, what did I say do? So we'll give it a name. We're going to call it Contour. It's internet facing. It's going to be doing, it's going to listen on TCP port 8080. All my stuff is running in, let's see, this VPC and the Contour VPC. Okay, so US West 2A. You have to essentially allocate an IP address from the NLB per availability zone that you're running in. So essentially say I'm going to list on port 80 in US West 2A. You go ahead, we're going to configure routing here. And again, I have like screenshots, everything here that we're going to have. For routing, what we're going to do, wait, did I click on this? Is Amazon thinking? What's going on, guys? Oh, at least one subnet must be specified. I thought I want to actually, let's see, what did I say I wanted to do? You want to select the public subnet. Okay. So logically, and then you can assign an elastic IP if you have one to this, which is kind of interesting. You can now have elastic IPs play double duty between your load balancer and your nodes, which is kind of cool. Actually, you could do that before. Okay, so we're going to create a new target group. We're going to call this Contour also. TCP, it's going to be talking to port 8080. So this is essentially the upstream servers for NLB. And we're going to point that at target type is instances, protocol TCP. You could do advanced health checking. We're just going to do the same old there. Let me make sure that that's essentially what we want. Yes. So now, right now, you could register the targets explicitly, where I could go through and click these things. Or we could go through, and I'll show you how to do this. We could actually, we're using an auto-scaling group. We could actually configure the auto-scaling group to go ahead and populate the target group for us. So we're not going to set any targets right now. We're going to go ahead and review this, and we're good to go, and I'm going to hit create there. But we're not done. So let's go to the target group here, and I'm going to go to targets here, edit, and then, oh wait, no. Actually, I got confused. What you do is you go to the auto-scaling group for this. And you edit the auto-scaling group, and I said, hey, I want you to actually go off and, no, not that one. I want you to go off and populate Contour, the target group. So now what happens is Amazon will take care of registering all the VMs, all the instances in this auto-scaling group with the target group that the load balancer is referencing. But we're not done yet. Because packets are coming directly into your instances, you have to set up your security groups for those instances to be able to accept traffic essentially from the internet. This is really kind of scary. Now, because I'm running, and this is the way that our Quick Start does it, because I'm running our nodes on a private subnet, this isn't that dangerous. Traffic will only come in through this port, through the load balancer. But if you are running on a public subnet and your nodes had public IP addresses, this would essentially open these things up for direct access outside of your load balancer, which means that there's a certain amount of sort of steering attacks for traffic, which is a security concern, and it's easier to DDoS because instead of DDoSing DOSing the whole pool, you can actually pick out and kill one node at a time, type of thing. So it's a little bit more dangerous from a security point of view if you don't configure this stuff correctly. So now we're going to go into the security group here, and I believe we set up this security group here, and right now, this is the security group for all machines in the cluster, I believe. Yeah, this is the one that we want. Yeah, because it's not the API server. Okay, so we're going to go ahead and edit that. We're going to add a rule, and we're going to be saying custom TCP 8080 coming from everywhere, and we'll say Contour there. All right, so Again, all this stuff is actually covered in, oh, I don't want to click on that. It's actually covered here with some screenshots so that we actually get this stuff going. So now, if I go here and I look at my load balancers, and we have Contour here and the DNS name. All right, fingers crossed. Let's give this a try. Uh-oh. That's not good. Maybe something's still coming up. Let's see what's going on here. So we have this load balancer. It's listening here, forwarding to Contour. We'll look at the target group Contour. It has targets, but these are an initial. The health checks haven't actually completed. Okay, so it takes a little while for the health checks to actually go. Chris is like, demos make me nervous. Oh, Chris. Oh, my poor sweet summer child. You have not seen previous TGIKs where things have totally gone off the rails. So, you know, there is that. We're always, oh, look at that, it's working. Okay, we're always flying without a net here. So this is great because what we see here, and this is the exciting thing, is that Envoy is seeing the IP address directly. So we've essentially reduced the number of hops going on here. So the network path is that it's going from my machine to Amazon. The Amazon network load balancer is doing some NAT, tunneling it through to port 8080 on one of the nodes in my cluster. That's hitting Envoy directly without going through any sort of like IP tables magic or bridging or anything like that. And then Envoy is then going ahead and sending that off to the backend services to Quardiv, which is running on cluster. So this is a really efficient setup. Not only that, but NLB has some really nice economics, especially when you're doing development. There's zero cost for running an NLB load balancer if there's no traffic going through it, which is actually really, really cool. ELB, they charge you per the hour whether or not there's traffic going through it. NLB, it's only the data that's actually coming through and connections that are coming through that charge. So especially for demos, or low traffic services, the cost structure of NLBs are really, really attractive. So yeah, that's pretty cool. That actually works. It's going to be even easier when you can set up NLBs via Kubernetes natively, because then we'll just be able to create a service like we did before and point it at these things. So that's really cool. ALB is really cool too, but ALB is a whole nother level where you're essentially having all the stuff that we might be doing with Envoy, you're actually going ahead and doing with Amazon directly. So is it possible to keep a long polling connection? I don't know about ALB, but with NLB, the network load balancer that we did here, I believe as long as there's a certain amount of traffic going on, it actually won't cut the connection. So as long as the connection is not totally idle, you'll actually be good, which is, I think in some ways more attractive than ELB Classic, where there's a limit to how long you can actually hold on to a connection. So yeah, all right. So that is a quick run through for Contour, some of the ways that you deploy it, what makes Envoy so special and why we picked it, and then a little bit of a demo of advanced configuration with NLB. Yeah, NLB, ALB, ELB Classic, it's very confusing. Matthias, I don't blame you for getting confused on that stuff. Now I want to show you my cool toy, my laser cutter. So what I did here is I'm going to make a Kubernetes Slinky out of wood, which is totally crazy. And I'm going to show you, I'm going to grab the camera here, and I'm going to move it around. And hopefully I won't unplug the camera as I do this. And let me go ahead and I'm going to switch to the main camera while I do this. You can see my messy office here. And I'm going to set up this camera pointing at this thing. So, okay, so first an overview. The thing's pretty big. That, the piece of wood that I have in there is I'm going to talk Imperial. I'm sorry, guys. And you may not be able, can you still hear me? Yeah, so the piece of wood that I have in there is 1/8" plywood. It's birch plywood. It is about 20 inches by 12 inches, which I believe is about 500 by 300 millimeters. And so I'm going to go ahead and I'm going to set up my camera pointing at this thing and make sure that it actually looks good so that as the thing actually goes, you can see it work. And then one of the other things you might have seen, there's a silver tube coming out there. That's a dryer exhaust tube. This thing burns things. And so you want to make sure that the exhaust doesn't actually come back into your room. The Glowforge is working on a filter that fits under it that'll essentially go ahead and filter things so that you can run it without that exhaust port. But that's not shipping yet. The regular Glowforge is. All right, so now I'm going to switch back to my screen and show you what's going on here. So this is this cool JavaScript library called Paper.js. And it makes it really easy to do sort of like vector graphics type of stuff in JavaScript. And so, oh, tree pun. Oh, you know, Chris, no, not the tree puns, please no. We could do Birch Ventures, right? It turns out that like every venture capital firm, almost all of them are named after trees for some reason. I don't even know. It's crazy. No, Chris, no, okay. I'm not. So this is I drew a heptagon spiral, and then I drew a heptagon around it. You can then go through and export this as SVG. And then once you exported it as SVG, you can go ahead and upload the SVG directly into Glowforge. And so I did that a while ago. And what happens is that comes in here like this. Now the Glowforge itself has a camera, the super wide angle camera that can take a picture of the bed, and you can actually sort of, oh God, Chris, no. Just leave. Just leave. So you can drag it into position on the bed to actually figure out where you want it to call. This thing's pretty accurate, but they're doing some really funky math here because it's a wide angle camera, which is pretty close to the material. So there's all sorts of like interesting mathematics to essentially de-warp the image out of this camera so they can actually give you this positioning stuff. Now, Glowforge itself sells materials that are already sort of like understood and qualified. And if you do that, then you don't have to play with any sort of settings or anything. I'm you know, somewhat cheap. And so I went out and I bought a sort of 5 foot by 5 foot piece of plywood. It cost about $15. And so that means that the cost of goods for me for this big piece of wood that's sitting in there now is about $1. So that's pretty cool. But what it means is that I have to go through and I have to actually put some settings in here. So this is about 1/8 of an inch thick. I have these calipers that I use. These like cool digital calipers. I don't know if like you can see these that I can use to actually measure thickness of stuff. So these are really useful if you actually start doing this stuff. So I can do so 1/8 of an inch, and then through trial and error, I figured out that if I set the speed to 225 and then I run it full power, that's going to actually give me a good cut. And so now what I do is, and you'll see it if I press print here. So that I think that looks pretty good. If I press print here, what it's going to do is it says scanning your material. And so what it's doing is it's moving the head there. It shines a red laser, and then it has another camera on the head. And it's using that to actually go ahead and really detect the depth and fine tune it so it can focus the laser appropriately. Let me adjust this camera a little bit. Now, the interesting thing, and this is good or bad depending on your position, is all of this stuff happens through a web service. And so the Glowforge connects via my home internet and Wi-Fi up to the Glowforge servers. The Glowforge servers then actually implement all of the really sort of funky logic. And, oh yeah, oh, what? An error occurred. I've never seen that before. Let's hit it again and actually see what happens. Yeah, I named it Kuberforge. So anyway, so the and then it's the Glowforge servers that actually do all the sort of like control and math and stuff like that. And so it really creates an integrated experience. And this is a heck of a lot more plug and play than a lot of the other sort of products out there that you can get. And so and over time they're going to be enhancing the experience, the tools that you have to work here. It also means that the amount of smarts on this machine is relatively small compared to the amount of smarts that are actually sitting in the cloud. Oh, and by the way, they're Kubernetes users. So I should, before I get too deep in this, I'm an angel investor in Glowforge because it's a friend of mine that was doing it. So there's a little bit of a pitch there around that. And early on, I helped them get started and I pointed them towards Kubernetes. So they're actually running on Kubernetes. And so this is Kubernetes running a laser cutter to cut out a Kubernetes Slinky. Okay. So now let me go. So now it's ready to go. It says it's going to take 3 minutes and 52 seconds. The warning here is essentially saying, hey, you're using your own materials. We can't actually guarantee that you'll get a good cut. But because for me, the stuff is so cheap, I don't care. I've done trial and error. I have this thing dialed in. So now I'm going to switch back to the other camera. And there's a big glowing button here. I'll show you the glowing button. So there's the glowing button. And if I go ahead, I'm going to press the button here. And this thing's going to start up. Let's see, can you see it? Let me move the camera. All right, so you can see it cutting there. It's a little bit loud. The fan only comes on when it's actually cutting. It's generating quite a bit of smoke, but the fan actually has enough airflow to move it out and then out my window. So it kind of smells like a campfire. And so, I guess my neighbors are getting a little bit of a campfire impact. So yeah, burn, baby, burn. There we go. And so we're at 3 minutes and 8 seconds left. And so you'll actually see this thing counting down as it goes. Now this can both cut and engrave. So what we're doing here is cutting. So it's actually doing a very, very sort of like width of a human hair type of cut around this thing. It also can engrave, where it uses lower power and it only sort of burns off a layer of the wood. In that case, it actually is kind of like a dot matrix printer, where it does scan lines back and forth, and it can do about 200 or 300 DPI is what I read. When you're doing that engraving, it ends up being a lot slower. So I'll show you like what the engraving. Let's see. I don't think I have any good engraving projects ready to show you. So but it's also pretty cool. You can do the engraving. It just takes a lot longer. So this demo is a lot better because it's doing the cutting. The total amount of sort of like linear cutting that's going on here, I'm really not sure. But I did this with a piece of cardstock instead of wood, and it pretty much like stretched all the way across my house. So there's, we're going to end up with essentially a really long, thin piece of wood out of this when it's all done. So Matteo says, I'd rather use it to cut pizza. So it turns out that people have used this to cut food. If you go on the Glowforge forums, I think somebody like etched a banana. So I don't know if anybody's done pizza yet. There we go. Got about a minute and a half left. What you could do, Mateus, is you could build a pizza cutting template. So you could use this to essentially make sure that you can guide your pizza cutter correctly at all times. So that's totally possible. So the materials that this will cut, it'll do wood. I've done up to 1/4 inch. I think you may be able to do a little bit thicker than that, but it gets more difficult. You can do plastic. Acrylic works really, really well. You can do cloth. You can do leather. I don't know where it went. I had a small Heptio logo that I did with leather. You can etch certain types of metal. And people have done all sorts of other things. The one thing that you don't want to cut is anything that has chlorine in it. So PVC specifically is a bad idea because it actually generates chlorine gas as you're actually cutting it, which can both kill you and go ahead and ruin the machine because it can corrode it. Yeah, so the cost, I think right now it's a pre-order. If you got in early on it, it was probably, I think around 2,000 was the price when it first started. Since they've entered production, things aren't quite as expensive as, I mean, things have gotten a little bit more expensive. So there we go. It's done. Okay, now I can stop yelling. And let's go ahead and look at it. So I can go ahead and lift the lid here. And it definitely smells like a campfire. And I'm going to lift out the... Oh no, it didn't. He must have had the power a little bit off because this is having a little bit... oh no, look at that. So this is one of the problems that we have here. I don't know if y'all can see this. And this is why the company sells this sort of proof grade material, is that there's a piece there's a piece where they probably filled in a knot, and so there was extra glue there, and it actually didn't cut through it as much as it could have, right? And so I could have gone with higher power, or I could have gone over it twice, and that would have actually solved the problem there. So this is probably a bad cut at this point. Which is the first one of these that I've actually gotten. And so this is one of the reasons why you might want to use the material from Glowforge, because they actually make sure that you're not going to hit problems like this. But this is me being cheap. But if I go ahead and I tear this out anyways, what you can see is that it's actually a little bit like, in this one again, because it didn't cut all the way through there. That's unfortunate. But I have another sort of similar one here that we can check out. Of like, so this is 1/8 inch plywood. It turns out when you cut it really thin, it actually turns into a slinky. So unfortunately, this is the first time I've had one of these things fail. So, so there you go. That's the Glowforge for you. And let's see. And so, yeah, so we're all talking about printing bacon. Yeah, that'd be great. And yeah, so it's it can be a complement to 3D printing, but you can also do 3D things with it yourself. So one of the things that you can do and if you go to, I'm trying to remember the name of the site, but there's all sorts of sites out there that will actually help you, sort of like do boxes that'll like finger joint together. So that actually ends up being really, really cool. Do I have to purchase additional fire insurance? No. Let me go ahead and move my camera back here. Let's see. Yeah, I probably should. Like, what I do have though is because safety first, I do have the fire extinguisher right here in case the whole thing lights on fire. So, so that's kind of fun. So yeah, so with that, I think I'm going to sign off. I hope everybody has a great weekend. If you have any questions about Contour or even the Glowforge, feel free to reach out to me on Twitter, and I'm happy to chat about any of this stuff. So yeah. Yeah, and I will put a bunch of links into the description for this video to a bunch of the stuff that we talked about, so that you can actually find it later. But you can also go glowforge.com and see it there. There's a really cool marketing video that they made when they first launched the crowdfunding campaign for the thing. So, all right. Well, thank you very much, everybody. And I will see you next week. I don't know what my topic's going to be yet, but maybe the resource stuff might be a good idea. I think CPU and memory resource limits and sort of best practices around that might be a good thing to do. So maybe that's what I'll end up doing next week. So, all right. Have a great weekend, and I will see everybody later.